Hello, good afternoon and welcome. Today my discussion topics is characterization of nanocellulose from wheat straw, fissile approach, the figure FTI spectra, raw wheat straw, alkali treated, bleach fiber, acid hydrolysis, and nanocellulose. This is nanocellulose. In the FTIR spectra, we're seeing the peaks in range of 3421. The stretching variation of the waistbone and similar peaks, small peaks near about the waist vibration of the cellulose, the peaks in the range of 2900 to 2930 per cm due to aliphatic saturated CS stretching vibration and the peaks see in the range of 1630 to 1650. In this range, the fix is due to carbon current double bond stitching and bending mode of absorbed water and 1195 the absorbed 1195 the absorbed SO2 from sulfuric acid in hydrolysis of cellulose, peak of asymmetric stretching vibration, and the peaks in the 624, the carbon sulfide stretching vibration peak is so the presence of SO3S group in acid hydrolysis treatment, and also another peaks 1430 find 50 and 1638.4 per cm and extracted nanocellulose show stretching and bending vibration of OH, CO, CS2 and CS. OH, CS and CO, CS2 vibration of cellulose and in the region of 1430 to 1450 CS stretching and 1370 CS or waist bending and 1050 to 1060 and 1060. This peak, this FTIR peak is the for CO stretching 897 per cm, CS deformation 897 CS deformation, vibration of the nanocellulose. This is the detail about nanocellulose, acid hydrolyzed cellulose, alkali treated cellulose, raw wheat cellulose of the IR spectra. This is the detailed explanation of FTIR spectra, and this is the XRD curve. This XRD curve shows the diffraction angle 60 degree, 22 degree, and 35 degree, indicating that extracted nanocellulose crystal adopt a crystalline structure formation, and similar results with other see the wheat straw, alkali treated, bleach fiber, acid hydrolysis, and nanocellulose of the similar structure of the diffraction angle, which shows the crystallinity of the nanocellulose. This is the explanation of XRD. This is the same this same result shows the mean area was reduced by 0.038 nanometer square, and the mean angle was reduced by diffraction angle 26.58, and mean length reduced by 0.629 nanometer. The same indicates the diffraction angle 26.58, reduce mean length 0.629 nanometer, and area 0.038 nanometer square. This is the explanation of same. This is the TAME spectra. The TAME spectra of the histogram shows the diameter of nanocellulose is 25 to 32 nanometer, 25 to 32 nanometer, which was 2% count, and 32 to 40 nanometer, which has the 5% count, it is the maximum, and 40 to 47 nanometer, which has 2% count, 47 to 55, 47 to 55, 47 55, which has 1% count. This is the histogram of TAME nanocellulose. This is the explanation of TAME of nanocellulose. This is the differential scanning calorimetry. In this differential scanning calorimetry shows the thermal behavior of the nanocellulose material varied from 0 to 400 degrees Celsius. The thermal behavior of nanocellulose 0 to 400 degrees Celsius. The endothermic peak was observed at 148, having the enthalpy 9.1167 joule per gram. Another sharp peak, endothermic peak, another sharp endothermic peak was observed at 193, range of 193 having the enthalpy of 49.276 joule per gram and another exothermic peak at 336.75 degrees Celsius with enthalpy 58.190 joule per gram. This shows the thermal degradation of nanocellulose. This is the detailed explanation of DSC. This is the thermogravimetric analysis TGA curve. This curve shows the initially smaller amount of weight loss was observed due to evaporation of water that is loosely bounded to the nanocellulose surface at temperature below 120. Temperature below 120. And the nanocellulose disintegration temperature is observed at 360. Observed at 360 to 850 degrees Celsius, and finally decomposition occurs. The nanocellulose disintegration temperature is observed at 360 degrees Celsius to 850 degrees Celsius, and finally decomposition occurs. This is the detailed explanation of TGA. This is the atomic force microscope spectra image in the 3D. This is the 3D image. Atomic force microscope studies about morphological and topographical structure. In the atomic force 3D image shows that the particle height is 3.2 nanometer from the atomic force morphological and topographical structural study. This is the explanation of atomic force microscopy of nanocellulose. That is zeta potential. The zeta potential, mean zeta potential value of minus 22.2 millivolt or negative charge and nanocellulose surface, which is the moderate stability. According to the zeta potential, the above the 10 to 20 millivolt is the moderate stability, and lower the 10 to 20 millivolt is the lower stability, and above the 30 millivolt is the good stability, and above the 60 millivolt is very good stability. The nanocellulose zeta potential range is the minus 22 millivolt, 22.2 millivolt, so that it is moderate stability. Is the zeta size uh, the particle size distribution of nanocellulose, uh, the zeta size, the particle size was the 58.77 nanometer with respect to the intensity. It's the explanation of zeta potential and zeta size. This is my reference. Thanks for watching.